Welcome to Module 4 of the GRR Technical Training Series. Module Aim and Reminders. This module discusses Requirement R7 of the GRR, the Site-Wide Environmental Safety Case, which we abbreviate to SWESC. This is the fourth GRR Technical Training module out of 8 in total. Before we discuss the SWESC requirement in more detail, it is worth just reminding ourselves about a few basic points. The GRR stands for the Management of Radioactive Waste from Decommissioning of Nuclear Sites, Guidance on Requirements for Release from Radioactive Substances Regulation, which was published in July 2018. The guidance is available on the SEPA website and can also be accessed via a summary on gov.uk. We use the term Radioactive Substances Regulation to cover the relevant legislation, which is different in Scotland from that in England and Wales. Although the legislation differs in detail, it shares common aims. We have written the GRR to fulfil those aims. Finally, please remember that the GRR applies to all stages of a nuclear site's life cycle, and that all the requirements of the GRR need to be addressed for the final surrender of a site's permit. What is the SWESC? So, what is the SWESC? To give it its formal definition from the GRR, the SWESC is a documented set of claims made by the operator of a nuclear site to demonstrate achievement by the site as a whole of the required standard of environmental safety. The SWESC is one of the two key deliverables that will be required under a nuclear site's environmental permit, regardless of the stage in the site's life cycle. The other key deliverable is the Waste Management Plan, which is covered in Module 3. Along with the Waste Management Plan, the SWESC provides the means by which the operator of a nuclear site should demonstrate compliance with the requirements of the GRR, both during and after radioactive substances regulation. GRR Requirements. This figure shows the structure of the GRR requirements. Requirement R7, the SWESC, is one of the 9 technical requirements in the GRR. The technical requirements and the management requirements both underpin the 5 GRR principles, which in turn underpin the fundamental protection objective. Requirement R7. Requirement R7 specifies that operators should maintain a site-wide environmental safety case to demonstrate that people and the environment will be adequately protected from ionising radiation and any associated non-radiological hazards, both before and after their site is released from radioactive substances regulation. Purpose of the SWESC. Purpose of the SWESC. The SWESC serves several purposes. The principal purpose of the SWESC is to demonstrate that the health of members of the public and the integrity of the environment will be adequately protected both during and after radioactive substances regulation. The SWESC is also the means by which the site operator should demonstrate a clear understanding of how the site will evolve throughout the period of radioactive substances regulation and after release from regulation. The understanding of the conceptual model of the site is an important foundation for the environmental safety case. The SWESC is the place where the site reference state is described, and if required, a period of control for the purposes of radiological protection is justified. The SWESC, along with the Waste Management Plan, demonstrates consistency with the 5 principles of the GRR by showing that all the management and technical requirements have been addressed. Site reference state. The site reference state is an important concept in the GRR. It refers to the condition of the site when the requirements in the GRR for release from radioactive substances regulation have been met. We will only grant release of a site from radioactive substances regulation once operators have demonstrated that the site reference state has been achieved. The site reference state is achieved when the SWESC shows that the residual risks presented by radioactive substances remaining on site, if any, are and will continue to be consistent with our risk and dose guidance levels without the need for controls. Please note that the GRR's risk and dose guidance levels are covered in further detail in Module 5, Understanding the Numerical Standards. Scope of the SWESC. To demonstrate full understanding of the site, the SWESC should describe all aspects of the site setting and conditions that may affect environmental safety, including but not limited to geology, hydrogeology and hydrology, biosphere, climate, landscape and surface features, and relevant engineering features. The geographical extent of the SWESC should be sufficient to construct a suitable model of how contaminants may migrate through the environment to potential receptors. The SWESC should take into account the potential consequences of changes in any of these site conditions, particularly long-term climate and landscape change. Because there is considerable uncertainty regarding many of these potential changes, in particular the rate and amount of climate change over different timescales, the operator should consider a range of scenarios using robust sources of data and explain their choice of scenarios. Potential source terms. The SWESC should take account of all radioactive substances in scope of the legislation remaining on and adjacent to the site. This figure, taken from the GRR, shows the potential sources. The outer red line represents the geographical extent of the SWESC, whilst the green area represents the permitted site. Note that the geographical extent of the SWESC may be greater than the permitted site because it needs to consider source terms that may have migrated off-site or past disposals outside the currently permitted area, as well as receptors that might be located some distance away. The source terms that the SWESC may need to consider include, but are not limited to, any in situ disposals of radioactive waste, whether in the form of below-ground structures or pipelines and drains, any radioactive waste disposed of for a purpose on site, such as for void filling, any ground or groundwater contaminated with radioactive substances, and any dedicated on-site, near-surface radioactive waste disposal facility. This last item must also meet the requirements of the near-surface disposal facilities on land for solid radioactive wastes, guidance on requirements for authorization, known as the near-surface GRA. Such a facility will have its own environmental safety case. Any facility-specific environmental safety case will form a component of the SWESC. It is worth stating explicitly here that the SWESC should also include any liquid or gaseous discharges while the permit is in place. SWESC contents. The SWESC can consist of a collection of resources that together meet our requirements. We do not require operators necessarily to produce dedicated documentation, other than, as a minimum, header or signposting documents. Overall, the SWESC should consist of a set of claims concerning environmental safety of the nuclear site, substantiated by a structured collection of arguments and evidence. The operator should provide robust and comprehensive evidence for any claim or assumption which the SWESC relies upon to demonstrate environmental safety. The evidence can either be qualitative or quantitative and should be structured in a logical way. We encourage the operator to discuss claims and assumptions with the relevant environmental regulator as they develop their SWESC. Quantitative environmental safety assessments. Whenever contamination is proposed to be managed on the site, and/or there are proposed on-site disposals of radioactive waste, we expect the SWESC to include quantitative environmental safety assessments to demonstrate consistency with our numerical standards. The numerical standards are expressed in requirements R9, R10, R11 and R12 of the GRR. More detail about these requirements is given in Module 5, Understanding the Numerical Standards. The quantitative environmental safety assessments should cover both the period of radioactive substances regulation and afterwards. The assessments should extend sufficiently far into the future to provide reasonable confidence that they cover the peak radiological risks, for example, from delayed releases of activity from disposals. But they should not be extended beyond a time when uncertainties have become so great that quantitative assessments cease to be meaningful. These assessments should explore the consequences of the expected evolution of the site after release from radioactive substances regulation, as well as less likely evolutions and events. For example, there is considerable uncertainty regarding future changes in climate and landscape. The quantitative environmental safety assessments should include less probable climate and landscape evolutions, as well as the most expected, particularly if the less probable evolutions are the most challenging scenarios to the environmental safety case. We expect the operator to complement the quantitative environmental safety assessments in the SWESC by making appropriate use of environmental safety indicators. These indicators might include radiation dose, radionuclide flux, radionuclide travel times, or radiotoxicity. Modelling studies. Modelling studies are likely to make up an important part of the quantitative environmental safety assessment. This figure shows a simple representation of a site conceptual model used to model pollutant flows through the environment. The general aim of modelling studies is to help in understanding the characteristics of the site and the behaviour of substances in the local environment. If modelling studies are likely to be extensive, we encourage the operator to consider discussing the modelling objectives with us at an early stage. Models and associated parameter values should, if practicable, be site-specific. Any use of generic data instead of site-specific data should be shown not to lead to an underestimation of the effects. Using generic models and parameter values may be more appropriate to the early stages of developing the SWESC or where the radiological hazard is low. In the SWESC, operators should provide not only the results of any modelling studies, but also details of the models and methodologies used. The operator should carry out a systematic and iterative programme of work to build confidence in the modelling. Multiple lines of reasoning. The uncertainties inherent in quantitative environmental assessments, including modelling studies, may mean that they can only give a broad indication of environmental safety. The operator should therefore use additional means, including qualitative understanding of the site, to satisfy us that people and the environment will be sufficiently protected. This may include, for example, qualitative site conceptual models which comprehensively describe the cause and effects relationships and feedback mechanisms present on the site. In this way, the SWESC should make proportionate use of multiple lines of reasoning, which lead to complementary environmental safety arguments. This may be particularly important when environmental safety must be assured over long periods of time. The reasoning, claims, and assumptions in these arguments should be clear and brought together in a structured way, supported by traceable evidence. Uncertainties. Uncertainties will always be present in environmental safety assessments, and the operator needs to understand and manage them when developing the SWESC. Uncertainties arise from diverse sources and have a number of different characteristics. They are caused, for example, by natural variability, practical limitations on sampling relevant processes and data, alternative interpretations of data, and natural events and future human behaviour that may affect radionuclide release, transport, and exposure pathways. How significant they are depends on the effect they could have on the arguments used in the SWESC. The operator should identify significant uncertainties and clearly explain them. The developing SWESC should include a strategy for managing them by considering whether they can be quantified and to what extent, and whether they can be removed or reduced. This figure shows our expected approach to treating uncertainties. Uncertainties which can be reliably quantified, such as measurement uncertainty, should be applied to parameter values used in the numerical assessments to assess compliance with the GRR numerical standards, as illustrated in the leftmost pathway in the figure. There are established methods for carrying out these calculations, and the SWESC should make clear which uncertainties have been addressed in this way. Some uncertainties cannot be reliably quantified. For example, if it is not possible to acquire relevant data, or if acquiring enough data to evaluate it statistically could only be done at disproportionate cost. Important examples of uncertainties that cannot reliably be quantified, or are effectively unquantifiable, include those associated with future human actions and climate change. One way of dealing with unquantifiable uncertainties about future events is through the use of separate risk assessments for each set of possible events. For example, for climate change, a number of variations in the possible progress of climate change could be considered. This is shown in the middle path in the figure. Some scenarios will involve future events so uncertain that it may not be appropriate to undertake numerical risk assessments for comparison with the risk guidance level, as this could distort the overall assessment of risks. These scenarios might include a range of what-if scenarios, and these should be considered one by one. This is shown in the rightmost path in the figure. Proportionate approach. An operator should maintain a SWESC that is proportionate to the complexity of their site and the hazards involved. A simple SWESC may be adequate for a site where the operator can easily demonstrate that no or very low concentrations or quantities of radioactive substances will remain on site. The SWESC will increase in complexity where there is contamination of ground or groundwater by radioactive substances and/or where the operator proposes to dispose of radioactive waste on site. Operators may choose to adopt a stepwise approach to the SWESC's development in order to ensure that the SWESC remains proportionate to the particular stage in the life cycle, the state of knowledge, and the hazards involved. For example, if their optimization processes support on-site disposal or leaving contamination in situ, operators may find it useful to carry out initial screening assessments of the likely impacts of the remaining hazards, followed by discussions with the relevant environmental regulator over the results, which in turn could be used to guide the development of subsequent versions of their SWESC. As stated earlier, the SWESC and Waste Management Plan need not be standalone documents, but can make reference to any documentation that provides evidence to support the case. However, there needs to be at least a top-level or signposting document that provides a focus for the SWESC. Relationship to the Waste Management Plan. The SWESC is closely linked to the Waste Management Plan. The need to develop and maintain a waste management plan is specified by Requirement R2 of the GRR, which is discussed in detail in Module 3 of this technical training series. Operators should ensure that their SWESC and waste management plan are consistent. The SWESC should show that implementing the optimized waste management options identified in the waste management plan will not threaten the environmental safety of the site and can be implemented in compliance with the requirements of the GRR. In this way, the SWESC predicts the impacts of the waste management plan, both during the period of radioactive substances regulation and afterwards. If it turns out that the waste management option selected in the waste management plan cannot be implemented without threatening the environmental safety of the site, then waste management options should be reviewed and the waste management plan updated accordingly. Therefore, the waste management plan and SWESC do different jobs but need to be consistent and may require some iteration between them before a final acceptable waste management plan is fully developed. We note that whilst the waste management plan should be maintained and implemented until all planned work involving radioactive substances is completed, the SWESC should be maintained until the site is released from radioactive substances regulation. For any application for on-site disposal, We will look at the Waste Management Plan and the SWESC together to determine whether we will authorise the disposal. Whilst the Waste Management Plan should demonstrate that the on-site disposal is the optimised option for that waste stream, the SWESC should demonstrate that the disposal can be made in compliance with the GRR requirements and that the site will reach a condition where it can be released from radioactive substances regulation and will do so within an acceptable period of time. We will talk more about the role of the SWESC in applications for on-site disposals later in this presentation. Groundwater and the SWESC. The EU Water Framework Directive and its daughter directive, the Groundwater Directive, are concerned with the protection of groundwater against pollution. The directives apply to the disposal of radioactive waste on or from nuclear sites and are a relevant consideration in determining whether a site should be released from radioactive substances regulation. Therefore, the requirements of the Groundwater Directive must be taken into account in the development of the SWESC. Groundwater protection legislation requires that inputs of hazardous substances to groundwater are prevented, and inputs of non-hazardous pollutants are limited so as to ensure that pollution of groundwater does not occur. These are often referred to as the prevent and limit obligations. Hazardous substances are those that are toxic, persistent, and liable to bioaccumulate, or because they give rise to an equivalent level of concern. Radioactive substances are considered hazardous substances. Radioactive waste may also contain other non-radioactive substances, which could also be a hazardous substance or a non-hazardous pollutant. The environmental safety evidence documented in the SWESC should demonstrate that the prevent and limit obligations of the Groundwater Directive will be met. Assessments modelling contaminant flows, such as the model shown in the slide, may be of particular use to demonstrate this. Inputs of radioactive substances to groundwater should be considered in terms of the radiation dose which might be received by people and non-human organisms through the groundwater pathway and any subsequent secondary pathways. Any such radiation doses will have to be considered in the SWESC when showing compliance with the numerical standards specified in requirements R9 to R12. Further guidance on the application of the Groundwater Directive to radioactive substances and to other pollutants, including on how to meet the prevent and limit obligations, is provided for England and Wales by DEFRA in the 2010 document Environmental Permitting Guidance, Groundwater Activities, and for Scotland by SEPA in the 2014 document Assigning Groundwater Assessment Criteria for Pollutant Inputs. In addition, further work is underway looking at the interface between radioactive substances regulation and groundwater legislation relevant to radioactive waste disposals on nuclear sites. Please contact the relevant Environment Agency for further information. Applications for on-site disposals. Operators must be authorised by the relevant environment regulator before they can dispose of radioactive waste on site, whether by emplacing waste or leaving it in situ. Authorisation should be sought by applying for a variation to the site permit. The SWESC, along with the Waste Management Plan, must support any application from the operator to make an on-site disposal of radioactive waste. For any application for on-site disposal, we will look at the Waste Management Plan and SWESC together to determine whether we will authorise the disposal. The Waste Management Plan should demonstrate that on-site disposal is the optimised option for that waste stream, whilst the SWESC should demonstrate that the disposal will not threaten the environmental safety of the site and can be implemented in compliance with the GRR requirements. The SWESC should also show that the on-site disposal will not threaten the site reaching a condition where it can be released from radioactive substances regulation within an acceptable period of time. Maintenance of the SWESC. The SWESC, as well as the Waste Management Plan, are live products that should evolve throughout the life cycle of a nuclear site. As such, the SWESC should be updated in light of on-site developments, new information such as new characterisation data, technical understanding or developments in radiological protection, and external factors such as changes in legislation and government policy. Updates to the SWESC should be at suitable intervals, and a comprehensive review should occur no less frequently than every 10 years. The updates should reflect growing knowledge about the site and should be consistent with the waste management plan. When making updates, the operator should consider how their SWESC will be structured and updated to ensure traceability and transparency. Operators should also maintain a detailed audit trail of changes made to the SWESC. The SWESC should be maintained until the permit is surrendered, as illustrated in the timeline. It is worth noting here that the waste management plan only endures until all planned work involving radioactive substances is completed. Summary. To summarise, the SWESC is a documented set of claims made by the operator of a nuclear site to demonstrate achievement by the site as a whole of the required standard of environmental safety. It should address the present condition and all envisaged future conditions of the site, both during the lifetime of the permit and after the permit has been surrendered. The SWESC should consider all radioactive substances remaining on and adjacent to the site, including any ground or groundwater affected by contamination. It should demonstrate that people and the environment will be protected from any radiological hazard and any non-radiological hazards associated with both radioactive waste and contamination. The SWESC should consider evolution of the site without operator control in the period after the permit has been surrendered. The SWESC is closely linked to the waste management plan, and operators should ensure their SWESC and the waste management plan are consistent. Next steps. This module has covered Requirement R7 of the GRR, the site-wide environmental safety case. While all training modules are designed to be viewed independently, we suggest that Module 5, Understanding the Numerical Standards, is viewed next. Thank you.